Welcome everyone to this webinar related to the future of test data management and why synthetic data can be your competitive edge. Today we are looking forward to deep dive together with you into the potential of using synthetic data as test data. And we'll be joining today with me and Marijn. I'm one of the founders of Syntho. I have a background in developing various data and tech applications. Typically, I work to challenges related to test data and privacy. And looking forward to deep dive today into the future of test data management with you. With me also Marijn.
Yes, hello. So my name is Marijn. Also co-founder at Syntho, indeed, mainly responsible for the product that we are providing at Syntho. Looking forward to the session today and dive into the product by dint of a demo as well. So looking forward to start.
Thank you. As for some practical information, if you have any questions, you can share them today via the chat so that we can cover them either during the presentation and demo or after during the Q&A. As for the agenda, we will start with an introduction about test data management with synthetic data. Then we will proceed with a live demo and we have time for Q&A in the end. The duration will be approximately 1 hour. As mentioned, if you have any questions, feel free to share them with us via the chat and we will cover them during this webinar. As for the speakers, I will start with the introduction about synthetic data generation and test data management, and Marijn will proceed from there with a live demo, where we discuss some of the technical details. Let's start with an introduction about Syntho. Syntho is founded in 2020 in Amsterdam, really with the mission to revolutionize the tech industry with smart solutions using AI to generate test data at scale, making it easy for organizations to have proper test data in a privacy-preservative way. We do that with our Syntho engine. That's our solution. With that, we really open and foster an open data economy where data can be used and utilized, but without compromises on privacy. As mentioned, we provide the Syntho engine and are winner of the Philips Innovation Award, winner of the SAS Global Hackathon in Healthcare and Life Science. Selected by NVIDIA as leading generative AI scale-up and winner of the UNESCO Gender Bias Challenge. And with Syntho, we really want to differentiate by utilizing smart and AI-powered solutions like artificial intelligence to minimize manual work and required configurations. We want to provide an all-in platform, making sure that you have all solutions in place. To make sure that we have an easy to use platform so that anyone can easily generate and maintain test environments, have high scalability, have built to manage large databases with minimal setup and computation power, with dedicated support by our experts to make sure that everything works smoothly. As for test data challenges, I really want to cover today about the challenge. You typically have your production environment and your non-production environments. Typically, those are your development environments, your test environments, your acceptance environment. And the challenge is really how to get proper test data there. What are the solutions in place to get there? And there I really talk from my own experience at the typical key pain points that we see within organizations that lack proper test data, they are there. The problem is typically that using personal data from production as test data is not allowed due to privacy regulations. And that forces organizations to think about introducing alternative solutions. And typically we see key challenges for organizations that do not have proper test data. And they are either categorized into one of the following problems. First of all, the problem is that test data does not reflect production data well. and that's problematic. What we typically see is unrepresentative data. Test data often fails to reflect the complexity and nuances of real production data. Had business logic inconsistencies. Generating data lacks the necessary business logic alignments, really leading to unrealistic test results. And finally, had the lack of referential integrity. Typically, you have data across a data ecosystem with multiple tables, multiple databases, multiple systems. And you want to make sure that there is consistency, referential integrity to make sure that you can do end-to-end tests across those applications. And that's typically challenging. And the second argument is typically related to test data generation that takes a lot of time and often also manual work. So what we typically see is there is high developer involvement. Your developers typically need to invest time, manual configurations, really reducing the focus on core tasks. You want to make them build smart solutions. And secondly, we see risky self-built solutions. In-house solutions are often unstable, leading to risks, and maintaining continuity can also be a challenge when, for example, your colleagues are leaving the organizations. And finally, test data does not cover all new scenarios. So there's limited coverage of scenarios. Current test data fails to cover edge cases, hypothetical scenarios, or future functionalities. And sometimes you do not have data at all for new functionalities. If you build a new functionality, there is no history, there's no data, and you need to have data relevant to do that testing. So these are the key challenges that we face, and I'm also curious to hear from you if you recognize them. If you maybe face different challenges, feel free to share them in the chat so that we can also discuss them today. What we also did was we asked some questions on LinkedIn via polls to the audience. And here we see some of the results. So the first question that we asked, what are the main challenges with test data? So we see privacy concerns, data availability, data quality was the biggest challenge that people see, and data relevance. We have a total of almost 400 votes. So that was quite interesting to see. So data quality and making sure that the data really reflects production data is obviously important. And secondly, we asked how much time do you spend on creating that high quality test data? So we typically see here also we have more than 100 votes that only 27% spend less than 25% of the time on creating the test data, and others have spent many more time on creating and maintaining the test data. And I think that's of course interesting to see that indeed test data creation takes a lot of time, and you want to make that as easy and smooth as possible. And that's really where we want to come in. We really want to turn test data into a competitive advantage. If you want to be front runner in building smart solutions, you need to think about the foundation, which is a proper environment to build, test, and develop your solutions. And generating representative synthetic data for the non-production environments can really allow you to deliver and release fast and state-of-the-art solutions. And what we see key benefits for organizations that use proper test data is, on the one hand, privacy by design and production-like data. So production-like data, we want to leverage AI to generate synthetic data that really mirrors the production environment while ensuring privacy. We want to maintain referential integrity, ensuring data consistency across data sets, across databases, across systems, as mentioned, with preserved referential integrity. Second, we want to have an easy and fast and agile solution. Fast, agile, and easy. And you want to quickly and seamlessly generate and refresh your entire test environment with minimal effort. We want to reduce manual work. We let smart solutions like AI do the work, and making test data generation and test data management more efficient. And finally, we also want to provide opportunities to have test data coverage for hypothetical scenarios. So comprehensive scenario coverage test data can be generated to cover both hypothetical future scenarios, ensuring full test data coverage. With rule-based flexibility, you have the flexibility to generate any data relevant for your test scenarios. And finally, generating synthetic data from scratch, create synthetic data even when production data is available. When no production data is available, really ensures that you can test new functionalities. So that is really what we want to achieve, turning test data into a competitive advantage, had to really realize business value. And the value that most of our customers see is release faster and shorten the time to market. Synthetic data really accelerates test data and development cycles, allowing for a shorter time to market, releasing the solutions faster. Spot bugs faster and earlier in the development cycle. So synthetic data can simulate that wide variety of edge cases, helping you to spot bugs earlier and preventing issues and escalations and later on in the cycle. First time right developments, by testing with representative and reliable synthetic data, you can really increase the chances of error-free production releases. Really go to first time right, reducing post-release bug fixing. Improve the test and development cycle and deliver with higher quality. And you really want to have the best quality of your software solution. Better test data can really ensure a more smoother testing and development cycle. And that, of course, improves your overall software quality and more reliable solutions in production. Utilize resources smarter by generating test data in a smart way. You can really allow your development team to focus on core tasks like testing and development, and not on overhead tasks like creating test data. The teams can then really focus on high priority tasks rather than spending time on test data creation and test data maintenance. And finally, of course, higher NPS score and net promoter scores. Of course, you want to have happy customers, and you want to deliver higher quality software production faster to boost satisfaction. So that is really where we are aiming for. So yeah, that is important to see. I think good to mention. I think also I received some emails on the back end that people have some challenges with entering the Zoom call. So I think it's good to check that on the back end side. From here, I really want to continue to the challenge. What we see without Syntho, how you will have challenges relating to your test data environment. So test data that doesn't mirror production data, that is not fully compliant, potential exposure of sensitive information, doesn't allow for variations of scenarios, minimize manual work. That's something you will miss out. And yeah, with Syntho, we really want to navigate to a solution where test data mirrors the production data, that it is a compliant solution, that we have privacy enhancing techniques that work well, and that allows for a variety of test scenarios with minimal manual work. And how do we do that? We do that with two ways. So we always illustrate Mimic. So with Mimic, we want to mimic a production data set as closely as possible. And we do that with synthetic data generation and de-identification. And we have Improve. So with Improve, we want to start with that foundation, a set that mimics the production data set as closely as possible. And from there, we want to improve it. So we want to make it better suitable for test data scenarios with either rule-based synthetic data and subsetting. And we will deep dive into then those solutions today. As a summary, and we will showcase them into details. On the one hand, we have AI-generated synthetic data, and there we aim to mimic statistical patterns of original data in synthetic data with the power of artificial intelligence. And the result is really a data set that mimics the original data set as closely as possible, but it's indeed fully artificially generated. So with that, you have the best privacy protection. To demonstrate the accuracy of the synthetic data, we always provide a quality assurance report where we compare the original data with the synthetic data. We work with external experts that evaluate our synthetic data on a regular basis, and it's optimized for time series data so that we even cover the most complex data sets. Second, we have smart de-identification. So de-identification is the process where you protect sensitive information by removing or modifying personally identifiable information, PII. Those are the direct identifiers such as first names, last names, and social security numbers. At first, we use AI to automatically scan which columns contain PII attributes, and that saves, of course, a lot of manual work. And then our scanners are able to really replace sensitive information, PII, with synthetic mock data. So we replace the real first name with a synthetic first name. And finally, and I think that's the most important functionality, consistent mapping that allows us to always replace the same first name with the same synthetic mock name to really preserve referentially integrity in an entire data ecosystem. And yeah, I think that works across tables, across databases, and across systems, even over time. And I think that's the most important functionality to preserve that referential integrity. And that's basically the starting point of test data management, where you want to create, maintain, and control representative test data for the non-production environments. As mentioned, we always start with de-identification and synthesization to generate a data set that really mimics the production data set as closely as possible, to create production-like data. And from there, we want to improve it to make it more suitable for your testing purposes. So with rule-based synthetic data, we can really generate synthetic data based on business rules, and that allows you to have the full flexibility to create any synthetic data set that mimics real world or potential future scenarios. Really allows you to tweak the data. And subsetting, and that allows you to create a smaller but representative subset of the database, and that allows you to have less computing power. We will deep dive into those solutions today. But before, I also ask this, would you be willing to adopt synthetic data for testing purposes to the audience? And I think also, great to see the results of this poll, where we see a great majority being willing to adopt synthetic data for testing purposes. And looking forward to deep dive into that today with you. Let's start with the deployment, because I think before we go into the demo, I think it's always good to explore how we typically deploy and make sure that the platform works safely and getting started. So as mentioned, our solution is named the Syntho engine, and I think it's important to mention that we always deploy our platform in the safe and trusted environment of our customers. So we can deploy on-premise, in the private cloud environment, or any other environment. And we do that via Docker or Kubernetes. And in that way, we as Syntho never see, process, or receive any of the real data as part of the test data management process. And part of that container is either a REST API that can be integrated into a data pipeline, or a Syntho web user interface that can be easily configured. And that's also what we will demonstrate today. As mentioned, the Syntho web user interface is not connected to the internet, just to a user interface to work with our platform in a user-friendly way. In our platform, we have various connectors to directly connect to your database for an end-to-end integrated approach. We always support the most frequently used databases. You can see them in this overview. They are natively supported in the platform, but if it is relevant, we can always create a new connector. And from there, I want to proceed with the live demo, giving the word also to Marijn. And as mentioned, if you have any questions, please share your questions via the chat so that we can cover them during the Q&A after the demo. I already see some questions coming in, so I think that is something we will cover during the Q&A after the demo. So if you have questions, feel free to share them via the chat.
Yeah, definitely. And indeed, we can cover them after the demo, but I think some of the questions we may already be able to cover during the demo. So let's actually proceed with that. So let me share my screen here. So like as Kees already mentioned, so this you see this the application is running in a browser. However, typically it runs within the secure infra of your organization. So it does not require any internet connection whatsoever. So that's for context. But from there, it starts like with most applications, you have to log in as a user. We provide email password login, also single sign-on, which can be relevant for organizational uses. So let's sign in. Then we actually land at this so-called launch your workspace panel. So this is where it all starts. So you can start by connecting to your data source that contains the potentially privacy sensitive data that you want to address. Or you can open an existing workspace. So let's say you have already done configurations for generating synthetic data before. You can just reopen those configuration in a workspace that you created before. So let's start by the case where we would start from scratch. So we would connect to a database. How does it work? What are the main steps? It starts by connecting to your source database. So that can typically be your prediction database, which contains the privacy sensitive data that you want to synthesize or de-identify. So you have to fill in the usual details, maybe enable some security options. And then as a next step, you will do that for the destination database. So that's where you're going to write the generated data to. So the data that you can then use for test purposes. So this could be, for instance, your a database in your testing environment. As a final step, I think good to mention because one of the core things of our platform is to allow you to generate synthetic data with speed. It starts with the deployment, of course, but the first next step is the configuration of your workspace. To help with that, you can define already on beforehand while creating the workspace what you want to achieve. So some options there are, for example, to synthesize, and then we are talking about AI synthesis, but also other kinds of synthetic data generation methods that we facilitate in the platform. We have another option, which we call mock all, which essentially means there is no AI behind, but you totally from scratch generate data entirely new. So that's typically relevant if you don't have any input data yet, for example. We have another variant, mock or mask all, where it also involves masking functions, or de-identify. So de-identify typically what it means is that you're gonna strip away the most sensitive parts in your database, being PII columns. So PII stands for personally identifiable information. Replace those columns, but leave the rest of your data intact. So those are the main typical cases you typically see within when you are talking about test data generation. Well, and why do you have to provide this beforehand? Because based on what you select, we will already pre-configure the workspace for all columns in your database with suggestions, suggested generators to synthesize your database. So that really helps you. Let's say you have a database of 100 plus tables with maybe 20 columns each. Then based on what you select here, it will already be transformed. It will already be put with a suggestion on how to generate data for each column by default. So directly after you created the workspace. So I just wanted to give this as context why this step is here, and it can really help you to save a lot of time configuring your data generation. Okay, but so essentially after this step, your workspace will be created. You will be directed towards this workspaces overview, where you have a selection of different, you can select the different workspaces that you have created. I will now pick this workspace called Patients Database, which contains, patient data, not real patient data, otherwise we could not use it for this demo, of course. But yeah, for illustrative purposes here, we have this, this particular database that we are gonna use in this demonstration. So I've opened it, and so from there we have now been forwarded to the job configuration panel. So on this panel you can configure everything around your data generation job, typically how does that work? So we split up our platform into two types of configurations. So on the one hand, you have table level configurations. On the other hand, you have column level configurations. So on the table level, you see the main configurations here on the left, actually. So in this left panel, we see we are connected to this database, contains some schema, actually only one in this case. And under that schema are a bunch of tables, 17 tables in this case. And those tables are currently listed under de-identify. But potentially, if I want to go for another use case, which is synthesize, I can also do that by dragging those tables under there. Well, actually, I want to just proceed with the de-identification use case for now. As we move along. And so those are some of the main table level configurations. I think some other table level configurations where we will get to in a bit are, for instance, the amount of rows that you wish to generate when you are want to generate data. So you can either decide to generate more rows as output, in case, for instance, if you want to do stress testing. The opposite can also apply, that you want to actually shrink the database. While of course preserving referential integrity, so keeping the logical structure and relationships across your database intact. So you can then also decide to downsize it. So so that can have speed improvements. It can also have make your test environment more flexible, easier to share, especially if you're working with extremely large production database, for example. Then you can potentially decide to downsize it to a referentially intact subset. So that's something you can also achieve by defining the number of rows to generate per table. And then the Syntho platform will essentially handle that the relationships are kept intact across those different tables. So then from there, we will move into the column level configurations. So I've now selected, for instance, this patients table. And we see under this patients table, we see all these different columns that reside under this table. And what you immediately see is that a bunch of columns are labeled as PAI. And and a bunch of other columns are not. So what does this entail? Those columns that are labeled as PAI, that's actually something that I did not do myself, but that came as a result of the PAI scanner. So again, talking about speed, if you want to de-identify, synthesize your database, you want to quickly get clear what are the sensitive elements in my database. And of course, you can do that manually by going through all the columns. But I think one of the core values of the platform is that we help you to identify those columns and then suggest how to handle those columns. So those PAI columns, here you see, for instance, the social security number column, driver's license column, passport columns, those are all labeled as PAI as a result of the PAI scanner. And so PAI stands for personally identifiable information. And typically, those are entities that can be used to directly identify an individual. So very privacy sensitive. And what I can do, I can go through, from here, I can, decide to handle these columns, do something with them. But I can also move to the PAI tab from there, where I get an overview of all the identified PAI columns. And from there, start to, replace those columns in order to protect them. So here on this screen, we see an overview of the PAI columns. As you can see, here we have 8 unprotected PAI columns listed on top, 0 protected, 17 non-PAI columns. So that means 8 unprotected PAI columns. Okay, we have to do something with those columns in this table. And we actually see those PAI columns listed below here. So this address column, for example, our PAI scanner has identified it as containing addresses. And it also actually indicates how confident the PAI scanner was that to detect it as PAI. Well, apparently it was 80% confident in this case. And yeah, actually it suggests already to apply a so-called address mocker, a generator for this column to replace it. So if I select this button here, I will actually see the suggestion that the PAI scanner came up with. So here it suggests to apply an address mocker. And if I preview the values, then we can see, okay, these are the values that come out from this address mocker. So these are all fake addresses, mock addresses, you could say as well. And so rather than keeping the original ones in, we will replace them with these ones. We can also decide, well, based on whatever locale my data is in, to change the locale, for instance. To be able to make it more look like production depending on your data. So we can confirm it as such. And now it's actually moving from this unprotected columns list to the protected tab. So our goal is essentially to move all these unprotected PAI columns to the protected tab. In this way, we can ensure that our entire table will be protected. So then here on the left, also this PAI icon will move, will go away. So that's structurally how you can handle this. I would do this for the first name column, for the last name column, and so forth. So these are a couple of examples. Here we have social security number column. We also here, for instance, have a passport column. And for that, I actually want to go back into my job settings view, where I can see actually some of the values that reside under the column. Because we have this driver's license column and passport column, and we see those have a very specific format. So let's say, I want to address this format S999, and then followed by 5 random digits in this case. Well, I can use that by a direct driver's license mocker, but I can also do that in a more custom way. And I think that's especially interesting in case you have particular PI identifiers which are maybe specific for the domain you're working in. Then you can also do that. We have quite some flexibility in the mockers we provide. We have 150 plus different mockers. So there, which gives you the flexibility to handle all these cases. So here we saw it starts with S999. Then we can follow it by 5 random digits by using this hashtag symbol. So it's kind of like a regular expression. So what essentially happens here, the S99 I just copied as is, but hashtag will be replaced with a random digit. We can also say, okay, because I saw some missing values in the original column, we can also say, okay, let's also simulate that like this. And then we have some missing values that are also occurring there. So that's a bit more of an advanced mocker, you could say, that we can apply in this particular situation. So we can also do that for this passport column, something like this, and so forth. So this is yeah, how we can deal with it. I think from now, like I actually already saw one question, like which is I think a very relevant one in test data cases, which is about like with test data you typically work with different systems which can be interrelated, and where yeah, you want, if you're going to generate test data, you want to ensure that the data is still consistent across these different systems, and even potentially over time. And I think that's an important question that we can address via our platform. But how do we address it? On the one hand, I think briefly want to mention we have foreign keys. So those look at relationships between tables, formal relationships that exist in our database and between tables. Well, what we do there is that we ensure that those relationships are inherited from the database. So those are called foreign keys. We automatically inherit them from the database, from your database, to ensure that the relationships between those tables are kept intact while we generate the new data. In case you don't have these keys explicitly defined in the database, for example, because you work with a system which does not allow you to define those foreign keys, or you have to find them on an application layer on top of the database. For those situations, we also provide the option to either upload the foreign keys in a JSON file or start a foreign key scan. So the scan will then, based on smart logic, will infer potential relationships between your tables. But yeah, this is all about relationships between key columns within your database. But then I think getting back to the main question, which was about how do we ensure also consistency across different systems? For that, we have a feature called consistent mapping. So Kees already briefly mentioned it in the intro. And now I want to demonstrate to you how this particular feature works. So let's say we have this city column here. And under the city column, we see a bunch of different values, but also see some values which are occurring more than once. So for instance, this Boston value is occurring 3 times here. So in the 5th, 6th, and 8th place, we see the Boston value. So what we want to achieve here, we want to replace this column with new fake city names, for example. But we want to also ensure that we consistently ensure that Boston is consistently mapped to the same output value. And we don't only want that to happen for this particular column here, but also in case we have another database where we also have a city column where we also have the value Boston occurring. So for those cases, we can use the so-called consistent mapping feature. So how do I do that? I apply a mocker, as I did before. But rather than just generating them as is, I enable consistent mapping. And what you can see here now, the 5th, 6th, and 8th value, which were in the original data, were Boston, the value Boston, are here now converted to these value Magia view. Interesting name. So that's how it works. So and even if you would apply these settings as well on another database, you will also ensure that Boston will be consistently mapped to this output value. So yeah, that can be very valuable, ensuring that consistency is maintained across different systems over time, which can be very, very important when for test data cases. I think another side note here, which may be good to be aware, although this feature is called consistent mapping, we do not actually store any mappings. So that may be a bit confusing, but so from a security perspective, that's actually what you want. You don't want to store the actual mappings, but do it in a more clever way. So we do that by using so-called seed functions underneath. So no actual mapping tables are stored anywhere. It works using a seed. You can also potentially rotate that seed value. So if you don't always want Boston to be mapped to a GeoView, so you may want it to be mapped to another value, then you can set another seed value, and then yeah, based on that set seed value, it will come up with a different mapping. Just for yeah, for any people who are more focused on the security aspects here, I can imagine that yeah, that's resolved this way. Okay, I think from here, so we now mainly looked at the de-identification, so replacing existing columns. Using, in particular, we focused a bit on the mockers. We can also look from here a bit on yeah, more maybe advanced cases where which can be also interesting in case you maybe don't have any data yet, but also if you want to define logic across columns. So to give an example here of a rule-based yeah, a rule-based case, what we may want to achieve is that is this, for instance, this first name column. Now I just plainly applied the first name mocker on this column, but actually let's say I want to fill this first name column based on what I see in this prefix column. So here I have Mr., Mrs., well, Mr. and Mrs. So let's say I want to fill this first name column with a male first name mocker if the prefix is Mr., and with a female first name if the prefix is Mrs. So how do I do that? For that, we can use a feature called calculated columns. Within calculated columns, you can define formulas. And how does that work, for example? So what I can do in this particular situation is I can write an if statement indicating that if the prefix column, so that's this column with the Mr. and Mrs. values, if that value is Mr., then I want to apply a first name male mocker. Well, I can say else, if that's not the case, I want to apply a first name female mocker. Well, I can also even write nested statements here if I want to go into more detail, more possible situations. But this is how this would work. So now, well, there will be either male first names or female first names depending on what we see in this other column. So this is an example of how you can facilitate rule-based synthetic data, and this can also be relevant for case, for instance, where you don't have any data yet and you want to yeah, maybe add additional columns with data. So yeah, that's a typical case where you can use this as well. All right, so as I think as a next relevant step, I think what's also good to consider is that with test databases or prediction databases, of course, they change all the time. So that's an important property of those prediction databases, is that they change all the time, often contain a lot of data. I will get to that in a bit. So how do we deal with huge amounts of data? But also the aspect that they change all the time. And with change, I don't mean only the data itself, but also the structure of the database. So it can, for instance, be that new tables are being added, columns are being removed, or added or changed even. So how does our platform deal with this? Well, I can give you an example here. So here we actually have a, in this database, you see this table called new table. And actually this new table is a table that, well, I added before, but I actually just now, before this demo, I removed this table again. So, but it's still in my workspace. So how do I resolve that? Well, for that we have a so-called sync option, which automatically syncs the workspace that you see here with your source database. So in this case, I actually removed this table in the source database. So if I go to the sync option, what will actually happen is that this particular table will be removed. So you can actually see here the change. So it's now grayed out, indicating that this particular table will now be no longer part of the workspace. So I can apply it, and now you can see it's no longer part of this workspace. So now my workspace is again in sync with the source database. So that's to deal, how we deal with changes that may occur in your production database. Another part is about, which is also often challenging if you're working with large production databases, can be speed. So how fast can you generate the data? So we now focused a lot on like, okay, the configurations of your workspace. So for that, we have a bunch of features I just walked you through which make this a relatively fast process. But you can, then the next step will be that you select generate, and you're going to generate and write the data to the database. So how do we ensure that this generation also happens fast? Well, we actually have a bunch of different options that we do there. I just want to highlight a couple of them. So one of them is subsetting. Actually, I already mentioned that. So you can use subsetting to potentially reduce the number of rows for a particular table. So let's say you have an extremely large table with a billion plus records, and you don't want the writing of that data is limited essentially by the speed of the database. So how fast the database is in terms of writing. So, if you want it to be faster, you can potentially decide to limit the amount of rows that you generate as output. So that's called subsetting. And subsetting also ensures that the relationships between tables are kept in place. Another solution, which is a little bit more on the technical side, but that is about how are we processing these tables. So in this case, we have 16 tables. And of course, you can process them one by one separately and after each other in sequence. However, if you would process them, for instance, next to each other, so in parallel, you can have really big speed benefits, up to the extent that essentially that the largest table becomes the bottleneck. So let's say, so how do I do that? Well, actually, I have to go to a couple of screens here, which I will just ignore for now. But yeah, here in this final step before I can say start generating, I can define the number of connections. This means the number of simultaneous connections that you can have with the database, which facilitates parallel processing. So let's, for example, say I set this to 10, then we can process 10 tables in parallel in the writing step in particular. So we already do parallelization before the writing steps automatically, but in the writing steps in particular, we can do this here in parallel as well. So that can have very significant speed benefits, as you may imagine, if you do this. And for instance, also if you combine it with the subsetting, as I mentioned. So that's one of, I think those are some examples of ensuring that we write ensure really speedy data generation and writing as well. All right. Let me see. Because we have a bunch of different other functionalities, but I was looking at the time a little bit, and I want to leave room for Q&A. That I just would say, let's go there. We have some options, like I think relevant with test databases, that you can share and you can control access to the workspaces. Role-based access controls. Those are all kinds of additional parts of the platform. But let's dive into the Q&A.
Yeah, thanks a lot. And as mentioned, if you have questions, please feel free to share them via the chat. We will also send a recap email where we will cover all the questions in detail. I think for now, one of the questions that we received is, how do you check the mock data validity? For example, the first name, how can needs to be representative. Social security number has a certain format. I guess that's something to consider.
That's a good one. Yeah, a couple of ways, but I think in general, I think a very good example is actually the social security number column. Yeah, at least I think for maybe the Dutch audience here, for the Dutch social security number, the number that comes out, it looks like a random number here, but actually this number should satisfy some kind of check to be able to check that that it follows the social security number formatting. It's called an ELF proof. I don't know to properly translate it in English, but yeah, so that all those that kind of logic, that's actually already predefined in the mocker. So as you apply this mocker on the Dutch locale, these values that come out of there satisfy these checks as well. So I think that's yeah, that's key to be aware of.
Yeah. Clear. I think I see also a question: can PII information be detected and adapted? Yeah, I think that's what we just demonstrated.
Yeah.
I think maybe a related question is Syntho able to handle blobs? I think the answer is yes. We will share that also in the user documentation. I think one question was how come that the PII scanner did not catch the birthday? I think that is something that is configurable, but yeah.
That's correct. You can actually determine which entities you want to look for. Now it also depends on the shallow and deep scan. Okay, I didn't actually go into that too much, but we have a shallow and a deep scan. A shallow scan actually only looks at the metadata, so column names, data types, yeah, some other entities, I think. The deep scan also actually looks at the data itself. So the deep scan uses more sophisticated named entity recognition models, well, these are kind of AI models, to help get to a more accurate detection. But yeah, here under there, you can also, under this PI entities to look for, you can also control which entities do you want to detect. And I think in this case, so let me see. So in this case, birth date and death date were not, well, we didn't include those to be detected. Because yeah, they are not direct identifiers, but that's a matter of yeah, what you consider PI. So we by default included those entities, well, based on also PHI, that's a formal definition of entities, a list of entities, I think in US, and PAI, the kind of entities that we enable by default as PAI. But you can also say, okay, hey, I also want to be automatically list those birth date and death date columns, for example, as PAI, and then it will also scan for those entities. Yeah.
Yeah. I think one question we also received is the generator capable to infer business rules? Are the business rules preserved?
Yeah, that's a good question, because actually one of the topics and of the generation methods that's also quite an essential one actually in the platform is AI generated synthetic data. We didn't dive into that too much today because yeah, because there's so much to cover. But okay, let's actually dive into that, because AI generated synthetic data in particular actually does this, but in a very clever way. So for that case, I would actually go to the synthesize option, so rather than de-identify. And yeah, to just give an example, so kind of business patterns, maybe more complex patterns even, that may exist in the data. How can I ensure that those are preserved while generating new data, of course, because I can, of course, leave them intact, duplicate them, then they will be preserved. But let's say we are sensitive and we want to replace them. So how do I do that? For example, so here we have this latitude, longitude, healthcare expenses, those three columns. And it can well be that there exists a relationship that a certain latitude and longitude, healthcare expenses may be higher or lower. Well, it can be location dependent a bit, so that at source of the locations, healthcare expense may be higher or lower. For that, to ensure that that kind of logic is preserved, we can apply AI powered generation as a generating method. Yeah, essentially how this works is that for all the columns that have this AI powered generation method applied, the AI will automatically capture those patterns and those complex relationships between those columns and reproduce it in the generated synthetic data. Yeah, so that's a very brief explanation of how this works. But yeah, so that this is one of the automatic ways to do this, essentially. Yeah.
I think a final question, because I think it's almost time, and if your question is not covered, we will make sure to answer it via email later on. Can you find PII and MaskIt also in text / unstructured data?
Yes, I don't have an example of, so I think that can be interesting indeed if you have columns with free text information. So an example could be that we would have a column here with doctor's notes. Maybe a doctor has just written some notes regarding a patient that has visited. Well, for that case, we have a PII text scanner, and it can actually also replace those detected PII entities. So let's assume this column, let's assume this column contains free text information. So how could we then actually handle this? We can do that by well, setting the generation method to duplicate. So that means actually just to copy over the data as is. But rather than fully duplicating it, we can enable this toggle detect and obfuscate PII. And when I do that, what it will do is it will scan the free text information for sensitive elements, so PII, similar as with the PII column scanner, and then it will list tag those values as PII. So, for instance, if in the doctor's notes there is a reference to a particular person or his birth date, social security number, then those will be tagged in that piece of text. We can also, instead of just tagging, we can also say to replace those tags again with new mock data. So yeah, so this is one of the options to do that. Yeah.
Thanks for sharing. I think, yeah, it is time. Yeah, I think, yeah, looking forward to cover any further question there might be. I think what's next, we will share with you a recap mail where we include the slides, the recordings, and we will cover the questions that have been requested during the webinar. And if there's any interest, we are there to provide you with any answer, maybe a tailored deep dive or demo session if relevant. And yeah, looking forward to connect in the future. So yeah, we will come back with a recap email, and if there are questions, always feel free to just send them in the chat or send them to me personally via email. We will make sure that they will be covered. Thanks you all for joining, and yeah, looking forward to seeing you in the future. Thanks a lot, and yeah, hope to speak soon. Enjoy the rest of your day. Thanks a lot, and see you soon. Bye-bye.
Thank you.